Determine for the function f of x equals 2x minus 1 for x is less than 3 and x squared minus 4x plus 8 for x is greater than or equal to 3 at the x-coordinate x equals 3, whether it is parts A through D. Each of the parts involves the continuity as well as the differentiability of this function f of x. For continuity, we're going to be determining if the two-sided limit as x approaches 3 of f of x matches f of 3. Since we have a split expression function, and it is splitting right at an x-coordinate of 3, we will need to evaluate the two-sided limit from each of the sides separately. So we will work out the left side limit as x approaches 3 of f of x, as well as the right side limit as x approaches 3 of f of x. Let's start with the left side limit. Left side of 3 is less than 3. From the split expression function, we can use the 2x minus 1 as the expression for f of x. Next thing to do is try plugging a 3 in for each of the x's. That will give us 2 times 3 minus 1, and 2 times 3 is 6 minus 1, which is a 5. We can now look at the right-sided limit. The right side of 3 is greater than 3, and that means from the split expression function we will use this expression for f of x. So we can replace f of x with x squared minus 4x plus 8. And now we can try plugging a 3 in for each of the x's. That will give us a 3 squared minus 4 times a 3 plus an 8. 3 squared is a 9, minus 4 times 3 is a minus 12, and then plus 8. 9 minus 12 is negative 3 plus 8 will be a 5. The last thing to evaluate is f at 3, which is evaluated for the expression where 3 is included. For the split expression function up here, that will be that expression. We plug 3 in for each of those x's. That will give us a 3 squared minus 4 times 3 plus 8. 3 squared is 9, minus 4 times 3 is minus 12 plus 8, and that also comes out to a 5. So we have the two one-sided limits match each other, so the two-sided limit will also be a 5, and f of 3 is a 5, and therefore this is continuous. Now, to determine whether it's differentiable or not, we are going to work out the continuity of the derivative. So the next thing that we want to do is find the derivative of the split expression function by taking the derivative of each function separately. The derivative of 2x minus 1 is a 2 for x is less than 3. And the derivative of x squared minus 4x plus 8 will be 2x minus 4. For x is greater than 3, we cannot put down equals to 3 just yet. You always have to keep these as simply less than or greater than until we see if this derivative is continuous at 3. So now we are going to determine the continuity of the derivative. So again, we're going to look at the two-sided limit of the derivative of f of x and compare it to the derivative evaluated right at 3. It is splitting at 3, so we will need to work out the limit from the left side and the right side separately from each other. Let's start with the left side. The left side of 3 is less than 3. F prime of x for less than 3 makes use of that expression. So it's a 2. And the limit of a constant is the constant. For the right side of 3, which means that we are greater than 3, we have this expression. 2x minus 4. Now we can plug 3 in for each of the x's. That will give us 2 times 3 minus 4. 2 times 3 is a 6 minus 4, which comes out to a 2. The last thing we want to evaluate is f prime right at 3. And the one that will include the 3, if anything includes the 3, is the second one, because the original function included the 3. It looks like the limits did match each other. And so f prime of 3, if we use this second expression, will be 2 times 3 minus 4, which is 6 minus 4, which is also a 2, and it matches the left and right side limits. So we can now go up here to the split expression function and include the equals right there. That can't be included until we see that the f prime of 3 matches the right-sided limit, and it did match it. And we therefore have the derivative is continuous. It has the left side limit matches the right side limit, matches the function evaluated right at 3. And so in this case we are situation A, which is both continuous and differentiable.